Hi guys, Ms. Redican here. Okay, so this week we're going to learn about other types of reactions. We've already learned synthesis, two things coming together, and decomposition, one thing breaking up. There we go. Okay, let's go ahead and get started. Okay, so science is a way of life. Science is a perspective. Science is the process that takes us from confusion to understanding in a manner that's precise, predictive, and reliable. A transformation. For those of us lucky enough to experience it that is empowering and emotional. So science, again, it's a way of looking at the world. Take a look. What do you think is happening in this image? What do you see with your eyes? And what might be happening at the atomic level to make this occur? Okay, we're going to come back to that. In fact, you're going to be doing a lab and studying a similar experiment tomorrow. Okay. We're going to learn about different types of reactions. We've learned synthesis and decomposition. We're going to review those. And we're going to learn about single replacement, double replacement, and combustion. And let's go ahead and watch our video together.
Identify the different types of chemical reactions together. Hello everyone, I'm Melissa Maribel, your personal tutor, and the first type of chemical reaction is known as synthesis or combination. Here's an example. In a synthesis reaction, two different reactants combine to form our product. Note, the reason why hydrogen and chlorine have a 2 subscript is because they are known as being diatomic molecules. Diatomic molecules are atoms that exist in pairs. Here is a list of diatomic molecules. Now, if we flip this synthesis reaction, you'll see it's now a decomposition reaction. Because in a decomposition reaction, you have one reactant that is being broken apart into multiple products. The next reaction is a single replacement or a single displacement reaction. Here's an example. Our reactants are one element plus one compound, and those form one element plus another compound. Notice that we are just switching the metals to form our new products. A double replacement or double displacement reaction is really similar to this because our reactants are now two compounds and those form two different compounds. Think of it this way. The inner elements combine and the outer elements combine to form our new products. Or you can think of it as the metals are switching again to form our new products. Up next is a combustion reaction, which occurs when something is burning. This is the general equation. And here's our example, where our first reactant consists of only carbon and hydrogen. Or we can have our first reactant consisting of carbon, hydrogen, and oxygen. Your biggest clue that something is a combustion reaction is that the second reactant is O2, and our products are carbon dioxide and water. These never, ever change. Now, in an acid-base neutralization reaction, we have an acid plus a base, and those form a salt and water. Now, if you're unsure what an acid, base, or salt looks like, an acid typically starts with an H, or hydrogen, and a base will end with OH, or hydroxide, and a salt is a type of ionic compound which consists of a metal and a nonmetal which have opposite charges. Predicting products is the next thing you're going to need to know, so here's a video to help you out. And remember, stay determined, you can do this.
Okay, so let's go ahead and write down some notes. Again, what happens? Oh,
Take a deep breath.
There we go. What happens in a go back. Okay, you get out of here. There we go. What happens in the synthesis reaction? So you have at least two. It could even be three. reactants coming together. In decomposition, you have one compound breaking up, splitting their bonds. In a single replacement, you have an element and a compound. And that one single element will replace part of the compound, leaving a new element behind. And the A replaces the B. In double replacement, you have two compounds and their ions switch places. Notice, if you're a positive ion in the front, like A and C, you stay in the front. Okay? So, a positive can replace another positive. In combustion, we have burning, and oxygen is required. No oxygen, no burning. Which two of these reactions are most similar to one another, and how can we tell them apart? Well, single replacement and double replacement are both replacements. How can you tell them apart? A single replacement involves an element and a compound. But a double replacement involves two compounds. Okay. Let's keep going. Again, we're learning about the differences in the formula for different types of reactions and how to identify different types of reactions based on their reactants and products. We've already learned that synthesis is when multiple substances are combined or put together. Decomposition is when one substance is broken down into components. Okay, so single replacement. Take a look. Which one of these is showing us a single replacement? Hopefully you chose this one. This is a compound, this is an element. Notice the C and the B are switching places this time. Okay. Notice the element does not have to come first. They just have to be on the same side. An element and a compound element on each side. That is a single replacement. Let's take a look here and make some predictions. Zinc is a positive cation. So is hydrogen. So the zinc can replace the hydrogen. In which case, then you get zinc chloride, and then the hydrogen is left by itself. Hydrogen always comes in pairs of two, so it's going to hook up with another hydrogen. Okay. Next, magnesium is a metal. It's a positive cation. It can only replace another positive cation, like the copper. So, let's do that. Let's make the switch. So then you're going to have magnesium with the chloride. Grab that too. And, oh, there we go. And now the copper is going to be by itself. So again, the zinc is a positive ion. It can replace another positive like the hydrogen. Magnesium's a metal, can replace another metal. Yeah. Notice element compound. Let's keep going. Let's look at double replacement. Take a minute. Which one of these is showing us a double replacement? Hopefully you chose compound, new compound. It's a replacement. In this case, the B and the D are switching or replacing each other, and they're both compounds. That makes it a double replacement. So, how can you compare a single and double replacement? Well, both have replacements going on, but single replacement involves an element and a compound, whereas double replacement involves two compounds. So they have something in common. They're both replacement reactions, but they also have their differences. A single replacement will have a single element involved, whereas a double replacement will have both things being compounds. Okay, let's see how well you do at identifying all kinds of reactions. Here's your notes. We've learned that synthesis, two or more things coming together to make one product. Decomposition, one reactant breaking down into more than one product. A single replacement, an element and a compound where a replacement of ions is happening. Double replacement where two compounds are switching their ions. Okay. Go through and let's see how you do. Okay, so hopefully here, looking at the very first one, we have a compound and a compound, two compounds. That should be telling you this is double replacement. Let's look for the replacement. The Na and the K are switching places, right? So you have Na is going to be with the OH, yep. And the K is going to get with the PO4, the phosphate. Double replacement. Next, take a look. Compound, compound. These are two compounds. And again, we have a replacement going on. The Mg is with the chlorine at the beginning, and at the end, the magnesium is with the carbonate. Lithium was with carbonate to start, but ends up with the chlorine. Double replacement. Next, going through, lead. Pb is lead. Notice it's by itself. That is an element. Iron sulfate is the compound. You have an element and a compound. We should be thinking single replacement. Let's look for the replacement. The Pb is by itself. The Fe is with the sulfate. They switch places. Lead, the Pb, ends up with the sulfate, and the iron is by itself. Again, this is a single replacement. Okay, we have calcium carbonate becoming calcium oxide and carbon dioxide. Notice we have one reactant breaking down. We should be thinking decomposition. Next, we have two reactants, tetraphosphorus and oxygen. Notice they're separate here, and they're coming together to make diphosphorus trioxide. So two things coming together to make one is synthesis. Last, aluminum by itself, it's an element. Copper sulfate, a compound. Making copper an element and aluminum sulfate a compound. We should be thinking single replacement. Let's look for the replacement. Aluminum is by itself. Copper's with the sulfate to begin. Then copper's by itself, and aluminum is now with the sulfate. So the aluminum replaced the copper. So it is a single replacement. Okay, let's take a look at a single replacement in action here in the video. So this was copper at the beginning. The copper is getting replaced by silver, which is in the solution. So the silver is replacing the copper, and you can see the liquid is now turning blue because the copper is entering the solution. They're replacing each other. You can see how silver and sparkly it is. This is how it started. Again, the copper is becoming part of the solution, and that's why it's turning blue. And the silver is coming out of the solution, replacing and forming on the wire there. It's a single replacement. Okay. Hopefully this helps. We're going to keep working on identifying all 4 kinds of reactions. These are the 4 we're going to focus on. And then our test is Friday. That's all for now.